Hello, hi everyone, welcome back to the channel. So I hope you're enjoying the series. You're learning something new from every problem which we are solving, and you are getting better at solving problems. So basically, if you want to get better at your problem solving skills, then you just have to solve random problems. When you're stuck, just try to read the solution, try to read the editorial, or try to read the codes of other coders, and then try to implement your solution, try to implement your own solution after you understand the editorial, because that's how you upskill yourself. Mere watching videos of the solutions will not help you to get better at problem solving, right? So let's solve this problem. In this problem we are given a subtree queries. The problem name is Subtree Queries, and in this problem we are given a rooted tree consisting of n nodes. The nodes are numbered from 1 to n. Node 1 is the root. Each node has a value, right? The task is to process the following type of queries. Change the value of node s to x, the first type of query. Calculate the sum of values in the subtree of node s, and that is the type 2 query, right? Now, how are we going to solve this problem? First, let's understand what the problem statement says. What for which we'll be using a test case. Okay, so let's take this test case where we are given a tree having 5 nodes which are numbered from 1 to 5. So we have nodes like 1, then we have 2, then we have 1 to 3, then we have 3 to 4, then we have 3 to 5. So these are the edges that we have here. Let's give some value to each node, because we are given a value of each node here. We can see that the nodes are numbered from 1 to n, and each node has a value. So let's give these values. We can see that node number 1 has some value 4, node number 2 has value 2, node number 3 has value 5, node number 4 has value 2, node number 5 has value 1. Okay, so we have given the value for each node of the tree. Let's see what are our queries. We have three queries, and we have two types of queries. The first type of query is change the value of some node s to x. This is the first type of query. The second type of query is calculate the sum of values in the subtree of node s. So the very first type of queries is something like 1, then s and x. Means if we are given like 1, 1, 5, 3, three integers, space separated integers, means query number 1, query of type 1. Node 5, change the value of node 5 to 3, right? That's how we define first type of query. The second type of query is 2s, means if we are given 2, 3, that means this is a type 2 query, and check for the node which is node number 3, which is 3, and for all the values in the subtree of 3, will be adding the values. Like for this node which is 3, add all the values here, 5, 2 and 1, and we'll get our answer. Okay, so that's how we have different queries. We have two types of queries, so let's see how we can process it. First, let's try to build the solution for this problem statement. Now the solution is simple, but let's first see the requirements of the problem. We need to process two types of queries. So how we can actually do this? Let's first think of the very simple approach to solve this problem. Then we'll basically move to the actual approach. We'll not go into real more depth and analysis of the problem, because in that case the video will be very long. Okay, so we have some value array. In this value array we are given these values for each node, node 2, 3, then 4, then 5. So we given these values like 4, 2, then we have 5, then we have 2, then we have 1. Okay, now what we can do, the very first type of query is 2, 3, that is second type of query. And for the node number 3, calculate the values in the subtree of that node. So calculate the values in this subtree, the sum of values. This is the very first type of query. So how we can process this type of query? So we're given 2, 3, type 2 query, find the sum of values in the subtree of node number 3. इंक्लूडिंग द वैल्यू एट नोड नंबर 3 एज वेल। ठीक है, ये करना अपने को। तो कैसे कर सकते हैं? टू डू सो ऑल वी हैव टू डू इज वी कैन we can basically calculate a subtree array as we have done in the previous problem, previous tasks. What we do is we basically pre-process a subtree array, let's call it sub, where each element 1 2 3 4 and then we have 5. For every node it basically stores the sum of all the values in its subtree. So like for node number 1, the values, the it will store the sum of all these values 4 2 5 2 1, 4 plus 2 plus 5 plus 2 plus 1. Okay, so we'll have 4 plus 2 6 plus 5 11 plus 2, which is 13 plus 1, that is 14. Then for node number 2 we'll have 2. Then for node number 3 we'll have 5 plus 2 7 plus 1, that is 8. For node number 4 we'll have 2. For node number 5 we'll have 1. Okay, now after that what we will be having is we will how we can process the subtree queries. We can see that for node number 3 all we have to do is just output this result, the result which is present at node number 3, position number 3. So we'll output 8. Now let's process the second type of query, that is update some value. So 5 3, that means update the value of node number 5 to 3. Update the value of node number 5 to 3. So node number 5 has a value 1, this will be updated to 3. Now this change of value, how much the value has changed? Initially the value was 1, now it has become 3. So the difference is 3 minus 1, that is 2. This is the difference which we have to add to all of the nodes which are there, which are connected, which are basically present in the okay. So we have to like add this 2 to all of the nodes which are there in the subtree of node number 3, right? We have to change the value, because you can see that changing the value of node number 5 from 1 to 3 here, from 1 to 3, if we change it, the value for the value for all of the nodes which which includes 5 as one of the nodes in their subtrees. जैसे node number 3 के subtree में 5 is a node, okay, node number 1 के subtree में 5 is a node. We have to change the subtree sum values for those nodes as well. Like if I have changed the value of 1 to node number 3 from like the value of node number 5 from 1 to 3, I have to change the value of the subtree sum for node number 3, and so for node number 4 as well. Okay, so let's do it. So this will be changed to 3, then move to its parent, that would be node number 3. We'll have to change this 8 because we will not have 8 now. We'll no longer have 8. We'll have 5 plus 2 plus 3, that is 10. So we'll have 10 here. Now move to its parent of node number 3, which is node number 1. We have the sum as 14, but here the sum would be will be increased by 2. It will become 16, because the difference, the extra portion, the extra integer, the extra difference which we have to add is 2. So we'll have to add 2 to all of the nodes which are ancestors of this node. Node number 3 is an ancestor of node number 5, node number 1 is an ancestor of node number 5, and so on. So we have to update the values in the subtree. This require going to every single parent of this node number 5, starting from node number 5, move to its direct parent, which is node number 3, then change its value, move to its direct parent, which is node number 1, then change its value. This can be accomplished using a parent array. So just store the parent of each node, direct parent of each node. So take an array 1 2 3 4 like this, 1 2 3 4 5. Then for node number 5 store 3, for node number 4 store 3, for node number 3 store 1, for node number 2 store 1, for node number 1 store minus 1. So from node number 5 move to node number 3, we can move here and update its value. From node number 3 move to node number 1, that is here, and update its value. From node number 1 we cannot move to any valid node or valid ancestor. So we stop here. So we basically covered every ancestor of the node for which we updated the value. That requires climbing up every single node of the current node for which we are changing the value. That requires a big of and time complexity in the worst case when we have a skewed tree. Okay, imagine a tree like linked list. Imagine a tree something like this: 1, 2, 3, 4, and 5, and so on. So if I change the value of 5, I'll have to move to every node and update the value of all of the nodes. That is going to give me a time complexity of big O of n. So this is the complexity for the first type of query where we are updating the value of the node. So if we have q queries, the time complexity for this query can be big Q into n if we have all of queries as updation queries. Now, what is the value, like what is the complexity for the sum query? The complexity for the sum query is constant because we are just returning the value from this subtree sum array. But updating this subtree sum array is the problem. And this solution is not going to work because look at the constraints here. Q and n goes up to 2 raised to the power 2 into 10 is like of the order of 10 raised to the power 5. So Q into n will be of order of 10 raised to the power 10, and that is going to take almost 100 seconds to execute for these extreme cases, which will not work, right? Because we can see the time limit is 1 second. You can see here. So we have to change our strategy to solve this problem. We have to improve upon it. Of course, this will not work because if this type of solution works, then I don't think there is a need for this problem to be put here in this problem set. So how to solve this problem? Let's see. The idea is simple. Let's take the tree 1, then we have 2, then we have 3, then we have 4, then we have 5, and let's put the values 4, 2, 5, 2, 1. Okay, so let's start. So let's start our DFS from node number 1. So what we can do is let's start the DFS from this node, and from this node I can move down to the tree, and let's see. So the idea to solve this problem is simple. All we have to do is we just have to, if we somehow, the problem is basically in the updation query. So if we can somehow represent this tree in the form of an array, right, where let's say I want to find the subtree sum for this node, then all of the nodes which are there in the subtree of this node must come consecutively. Fine. In this fashion, if we can do so, let's say if we have an order something like 1, 2, 3, 4, 5. So you can see that all of the nodes which are there in the subtree of any node. So for instance, in the subtree of node number 3, we have 3, 4, 5. In the subtree of node number 1, we have all these nodes. What we can do is we can sum up the values for these nodes, right? We can sum up the values for 3, 4, and 5. So the problem reduces to calculating the range sum of these values, right? Range sum of these values. Range sum of from 1 to 5, range sum from 3 to 5, and so on. So calculating the subtree sum values for node number 3, all we have to do is move to this node and just calculate the values for the next 3 nodes. 3 is basically the size of this subtree. That's all we have to do. So what is this? This is nothing but flattening a tree. Flattening a tree, which can be done using Euler tool or Euler tool. Okay, so all we have to do is just flatten this tree and build a segment tree to perform the range query. That is range sum query, finding the sum of like finding the sum over a range of values. That's what we have to do. And again, we know that how segment tree works. It performs a query in log of n order, and for q queries we'll have q into log of n complexity. This is basically how the sum query works. How will updation query work? It is also easy. So let's let's see how what we are trying to do here. So first of all, I will build a time array, time in array, in time when we are moving onto a node. So starting from node number 1, we are moving on this node. We're visiting node number 1 at time 1. Then we're visiting node number 2 at time 2. Visiting node number 3 at time 3. This is the end time when we are basically visiting that node for the very first time. Then we're visiting node number 4 at 4. Then we're visiting node number 5 at 5. This is end time. Now, after that, we'll basically build our array. Okay, so this array can be, it's like start from node number 1. Now, what does this time in array suggest us? It basically gives us the flattening of the tree or the Euler tour of the tree. Basically the way, the order in which we are visiting the nodes. So for any node, let's say for node number 3, I will be visiting all of the nodes in the subtree in the continuous fashion. So 3, 4, 5 will be visited in the continuous fashion. Now we'll build the array like this. So we know the values. So let's say for this index, which is value of, which is for the very first index, for the very first node, the value is 4. Now move to node number 2, and for this the value is 2. So let's just take another tree. Let's not take this tree. This is too naive. The example is too naive to understand this problem. So let's take this. The thing is simple. Let's calculate the in array. Let's calculate the in array. Now the in array is basically the time when we visit any node. So start DFS from node number 1, and the time when we visit node number 1 is 1. Then we visit node number 3. So the time when we visit node number 3 would be 2. Then visit node number 2. The time when we visit node number 2 will be 3. And then we visit node number 5. The time for which would be 4. Then the time for node number 4 would be 5. This is the order in which we are visiting the nodes. This is also called flattened tree. So we have flattened the tree basically. Now, the second thing is we're going to build the array. We build order array. So this array is basically for the order in which this array will be used to order the values. Order the values in the order of Euler tour, because we want to build the segment tree over these nodes, but we basically want to find the sum of values in the range, right? So we want to order the values in the same order in which we have our nodes, right? That's why we have to use one more array for ordering the values of these nodes in the order in which we have our flattened tree. So the flattened tree is like 1, 3, 2, 5, 4. The values will be, for node number 1 the value is 4, for node number 3 the value is 5, for node number 2 the value is 2, for node number 5 the value is 1, for node number 4 the value is 2. This can be done like this: ARR of in of that node, for that position assign the value which we have for that node. So while we are performing the DFS, when we are flattening the tree, we will also use this assignment to prepare this array, right? Now we have our array 4, 5, 2, 1, 2. Like if I want to find the subtree sum of this node, the subtree sum for the subtree sum in of the values of the nodes which are there in the subtree to red node number 2, all we have to do is to sum all of these three values, right? right? Sum 2 plus 1 plus 2. That's what we have to do, right? So let's do it. Now, let's build the segment tree over this array. And then all we have to do is to perform the range queries, right? So let's see, for the very first query we have 2 3, we have 2 3. Basically this is a query of type 2 and we have to find the sum of values in the subtree rooted at node number 3, right? Rooted at node number 3. So okay, so this is not same example as given here. We have tweaked the example a little bit to understand the problem better, to understand the solution better. So if I want to find the sum, so we have 2 here, right? Let's take this query, that is find the sum of values for the subtree rooted at node number 2. So find 2 plus 1 plus 1, 2 plus 1 plus 2. The answer would be 5. So all we have to do is move to this position and find the sum of the range from this position. What is this position? The position for node number 2. So we move to in array, we move here at the second position, we find 3. Basically we enter node number 3 at position number 3, right? So we move to position number 3 in this array, 1 2 3. So we move to this position. That's how we locate the starting position into this array. Fine. So we are given 2, we find the value at this position, we have 3 here. Now move to 3 here. This is the starting point. And now we also have to know the subtree size. The subtree size is 3. Means we have to find the sum of values starting from this value for 3 consecutive positions. So from 2 1 2. So 2 plus 1 plus 2. The answer would be 5. This is what we have to do here. Okay, so I hope you got the solution. So how are we gonna find, how will the update query works? This is how the range sum query works. Let's see how the update query will work. The update query for so for performing the update query, all we have to do is to update the position. Update is just to use that update function which we have been given in the segment tree. So for this, implementing the solution of this problem, you must know how segment tree works, how the sum query works, how the update query work. All we have to do is just perform the point update for the position, for the relevant position which we are given. So let's say we are given type 1 query in which we want to change the value of node number 4 to 2. So to, let's say, 5. So all we have to do is move to node number 4 here in this array. That would be here, move to node number 4, which is this, and it is present at position number 5, which is this one, right? So find the end time for that node, which is 5, and that basically represents the position of the value of that node which is there. So we have to update this 2 by 5. That's how we perform the point update. And we'll also update the corresponding segment tree values. That will also take log of n time complexity. So log of n time complexity for the update query, log of n time complexity for the sum query. And for Q queries, we'll have Q into log of n time complexity for performing these Q queries. So that's the time complexity for this solution. Let's jump to the code implementation part. Okay, so this is the implementation of this problem. Now this is the adjacency list in which we will be storing the tree. This is the array to store the subtree size. This is the segment tree, and this n represents the number of nodes. This is the timer variable which is used to store the end time. Now start time is stored in this array, values of the nodes are stored in this array, and this array, this ARR of max n, this will store the values in the order which we have calculated in this start time array. Right? So we have calculated a certain order of the tree in this array which will be stored in this array. Right? Now here we have our build function of the segment tree, here we have our update function of the segment tree, here we have our sum function of the segment tree. Now there is nothing new in this. I have just copy pasted the code from the CP algorithms website to just perform these operations. Now here we have performed the DFS to compute the end time of each node and to basically order the values which we are given according to the end time of the nodes, so that we can build the segment tree over this array. Then we basically perform the DFS, and here we are computing the subtree size. So we know how this function works. We have learned it in the previous videos. So if you don't know how to calculate the subtree size, please make sure to watch previous videos like this problem subordinates where we understood how this function works. So here we are basically taking the number of nodes, the number of queries. Now here's the value array. Then we prepare the tree. Then here we are calling the DFS function to prepare our start array, that is the end time array, and the array for which we'll be building the segment tree, the array of values in the order in which we are visiting the nodes. Right? Now build the segment tree. So we are basically reordering the values, then we are building the segment tree over those reordered values. The order in which we are reordering them is according to the end time of the variables, because we want the subtree values in the continuous fashion. Right? Now after this, we have built our segment tree here. Then we'll perform these Q queries, and this T represents the type of the queries. So if we have first type of query, then do something. This is the update query. Basically update the value at this position x to s. So that's we perform the update query. Start s is represents the end time of that variable, because this start s behaves as the index of this array ARR. Okay, that's the thing. This behaves as the index of that array. And what is this x? This x is the new value. Okay, so update the value in the array ARR array at this index to this new value x, and like updating the segment tree. Then we also update the value in the array itself. Let's see the second type of query. Here we have to find a subtree sum in this tree rooted at node number s. So all we have to do is to call this sum function for the root vertex. Then this is the range in which you want to find the sum, like the maximum range, the range of the array from 1 to n. This is the starting index of the range for which we want to find the sum. And what will be the ending index? The ending index will be the starting index plus the subtree size, the number of nodes which we have in the subtree, because all of the nodes, the node values will be in consecutive order, right? And then minus 1. Okay. So this is the starting index, this is the ending index, and this will give me my sum of subtree values in that subtree rooted at node number s. Fine. So that's all we have to do. in this problem. I hope you got the solution. This problem was a little tricky, but when you solve such problems, like when you practice such problems like 2, 3, 5, 4, 5, when you practice a lot of like when you practice such problems more frequently during contests, or like when you practice such problems more frequently, you become better at it. Okay, so again, attempting such problems, then getting to the solution is basically the crucial point. You have to be patient to get to the solution of any problem, because these type of problems requires patience, right? Although it was straightforward, but there was a little trick involved while solving this problem. And all of the subsequent problems also involves the same concept, that is Euler-Tour concept, for solving them. So you can try the next problem, which is path queries, which is very similar to this problem. So if you have understood the solution of this problem, then don't just jump to the solution of this next problem, which is this path queries. Okay, the problem again you can see, change the value of node s to x, again a query problem. Calculate the sum of values on the path from root to node s. Okay, two types of queries. Well, we can use the same thought process to solve this problem as well. So the what is the key learning from this video? You just have to learn how you can think about problems. What is the process to think? How we can start from a very naive brute force solution. Then we can think about the optimizations, where we can perform optimizations if we have some standard algorithm to basically solve this type of task. And how we get to know that, yeah, this like how we get to know that, yeah, for this type of task we can use that algorithm. Like here we could see that, okay, we had to update, we had to perform, we have to use segment tree, right, to perform the updates here and to find the range sum. How we come up at this conclusion? Because I knew the working of segment tree. Why do we use segment tree? So that comes with practice and solving more and more problems, failing at them, then looking at the solution, understanding the solution, coding it, again solving problems and repeating till, and in this fashion you will see more and more problems, you will see more and more solutions, and that's how you get better at solving these problems, right? That's all. So that's all for this video. If you like the video, then hit the like button, and make sure to subscribe to the channel, and I will see you soon with the next video.